located at the right side portion of your screen. So you will see there the chat box to which you could address your concerns or your items for clarifications, your questions to the host, to the panelists, and the presenter. Or you could also post your questions at the Q&A chat box. So your questions will be queued by our group of panelists. So aside from our presenter, our resource person for this afternoon, we also have a group of engineers who will be ready and are on standby to answer your questions at hand. So questions will be addressed at the end of the presentation during our Q&A segment. So bakit po hindi agad masasagot during the presentation? Siyempre, we would like for our presenter to have a good flow of his discussion, of his presentation. Okay, so we have a dedicated time or segment for your questions to be addressed. And of course, we would love to hear your feedback. We hope you can answer the quick survey right after this session. Ipopost ko po yung link dun sa ating feedback survey. So we hope you can take time. It's just going to be a few questions so that we could help you better in our coming sessions, and we could improve for our continuous improvement. Okay? So during the sessions, ito po yung sinasabi ko, at the right portion of your screen, meron po dyan panel. So meron tayong feedback button. Yan po yung maliit na megaphone, that small megaphone. So if you would like to send a feedback to the presenter or to the host, you can just click this button, okay? And you can choose amongst the different icons in that button. So meron siyang button for smiling face, meron din button dyan for a check, meron din pong button for applause, which is usually a pair of hands. And then ito yung sinasabi kong chat box kanina, okay, and the Q&A box. So you just click this one, and then you can type in your questions or your items for clarification. Okay? So this is the ABB Philippines Webinar Series 2020. Welcome po. I will be sharing with you some of the webinar sessions that we will be having for the month of July. So on July 16, we're going to have the digital MV switchgear. Presenter is Sujay Kalhans, our product marketing specialist from ABB India. And on July 30, okay, we're going to have the short circuit calculation based on IEC 60909 with our resident expert, Engineer Tristan Ocampo. And for the month of August, we're going to have a session on free at-home solution for residential applications. And on September, we're going to have the Safe Ring Air to be discussed by Engineer Alan Bonagua. On October, we're going to have a session on substation bay level communication using IEC 61850 for Reliance Series 615, 620 protection relays. And on November, the topic will be ABB Smart Trip Unit for MCCD and ACD. And capping our 2020 webinar program lineup will be a topic on smart grids via ABB solutions. Okay? So you may check out the latest webinars that we have at hand. It's this is the website. Okay, this is our official local microsite for our webinar series. And when you click our website, you will see the different buttons for the various webinars that we have at hand. So every month, usually, meron po kaming nilalabas na new add-ons for our webinar lineup. So what we have shared with you are already plotted for the rest of the year, but nagdadagdag po kami every month. So you just have to, stay tuned with our announcements. And for those who are asking about our channel partners in the Philippines, you may also find it in our website. And, oopsie. Okay, so at this point, I would like to ask if our presenter this afternoon, JJ, are you there?
Good morning, everybody. Good
Hi,
afternoon,
go ahead.
everybody.
Good afternoon. So at this point, I'd like to turn over our virtual mic to our presenter this afternoon, J. Lee. JJ, please take it away.
Okay, thank you. Can you see my share screen?
Yes, JJ, we can see your screen.
Okay, thank you. First of all, thank you for all of your time, sir, to have a look at our product ranges. One of the product ranges, SPD, surge protection devices. You may heard about. ABB, the name of the product ranges is OVR QS. QS is a stand for Quick Safe Technology. You will see later what is the meaning of this QS as Quick Safe Technologies, especially in Type 2 coordination ranges. Again, my name is Jae-jun Lee. Please call me JJ. I know this is much easier for you to call my name. I'm area sales manager for ERSB Smart Building, one of the divisions in ABB from the July. I'm actually in charge of Korea, Japan, and Taiwan and Philippine market for sales and marketing. For the Philippines, it's quite new for me since I hand over the Philippine market from the last year, from May. So currently, I'm still learning the market demand together with you and our colleagues in ABB Philippines. So for the 1 hour, I really would like to show our SPD product ranges for you. And also, I would like to take these chances to learn from you what is the real demand from the Philippine market regarding of the surge protection devices or solutions, whatever. So hope you enjoy it. I will start. So before we start, here you can see also some direct lightnings from the cover pages. So why we put in the direct writings from the starting pages when we're talking about the SPD? Here is also I put from my first slide again the direct lightning strike from the sky. So surges, which is the our OVR as a SPD, have to be protected against is actually normally generated from the direct lightning from the sky. So you know this is having a huge powers, huge energies. So somehow inside our buildings for all kinds of load will be impacted if there is no special protection equipment in there. That's the reason why we know very much, or we're learning every day how important to install the such protection devices in our conventional electrical equipment or electrical distribution board, final board, whatever, especially raining seasons for sure. So in further 45 or 50 minutes, I would like to explain about starting from the standard about the SPD. The second is the definition and what is the meaning of the SPD. And we will see how SPD operated against the surges. And last, we would like to see some basic terms. And finally, I didn't mention in this contents, but in the last 10 or 15 minutes, we will see some product overview of our SPD ranges. So when you have any kind of the questions, please feel free to comment or write down the Q&A sessions. Then after finish the overall presentations, then we will see your questions all together. All right, starting from the standard, SPD is actually have a lot of the standard, starting from the IC 61643. I'm not sure you are aware of this IC standard, or there is also another standard, EN, European standard, and the UL1448 now fourth edition, including the DC network. This EN, UTEC, and the UL1449 is SPD, but especially from photovoltaic applications like high level of the DC voltages up to the 1500. And there is another IEC standard for the SPD and the EN standard 62305. So when you look at the specifications, whatever they need a solution or products according to this kind of the standard or approval, this is the linked to the SPD, like from ABB, name of the OVR QS. This is quite the interesting table for me. So there is a lot of the different standard comply with the SPD. One is the for sure international standard IEC and the European standard EN and NFC VDE from Germany, UL from the US market. Then on the different approval, on the different standard, there is the classified type of the SPD, like type 1, type 2, type 3, or class I, class B, class C, class D, or like a TVSS according to the UL. So they are all calling the same products, but with a different name according to the different standard. So when we're talking about type A, type 1 is according to the IEC standard or EN standard, but according to the VDE in Germany, they call class B. Sorry, something was not qualified, but if I keep going, type 2 is also like a class C according to the VDE. Type 3 is like a TVSS according to the UL. So this is I just try to put this table somehow to let everybody on the same pages what we are talking about for these classes. I'm not sure whether you are much prefer according to your demanded type 1, type 2, type 3, or class A, B, C, D, or TVSS. As far as my experiences, my short experiences in Philippine market, TVSS is the much more recognized by the customers at the moment. So, like TVSS is stand for transient voltage surge suppressor, according to the UL, and according to UL 1443 third edition, now fourth edition is established, but according to the UL third edition, which is issued 2009 September, they mentioned that now they will not use this TVSS as names for the SPD anymore. But I know some countries still use the TVSS. This is just for your information. SPD, according to the IEC standard, for sure stands for surge protection devices. Also, you may heard that many times surge arrestor devices designed to limit the transient voltages. Actually, these surge arresters we can easy to hear from the medium voltage side. So basically, TVSS, SPD, surge arrestor, they are different names, but at the end, the target of the products is all same, to limit transient over voltages because of the direct lightning or indirect lightning or whatever. So hopefully this is clear for you and helpful for you understanding about the SPD from the different name of the products in the market, in the global market. So now we will see some report is that in total electrical fault, we try to define that what is the main reasons why make some fault. So this is the root cause analysis according to the study in France. as you can see, more than 61% is because of the voltage surges. So directly linked to surges, or because of the surges due to some high over voltages is one of the key root causes to make our load devices will be broken down. So SPD, the demand is getting higher because of those kind of the recognitions by the customer side. Then I will try to explain just for better understanding about the SPD. From this slide, I would like to explain what type of the surges they have. From the beginning, I mentioned one is the direct strike from the sky. So this is the one typical type of the surges I would like to say. So from the sky, direct lightning to the lightning rod on the house, on the rooftop of the houses, and going through to the ground. Second is for sure indirect, not directly to the lightning rod, but directly direct lighting to the like a tree. And after hitting the trees, the energies will be spread out and to the electrical network indirectly with having such a big energies. So this kind of the surges we call indirect strike. And another type of the surges, same on the indirect strike category, but we call usually switching devices, switching surges, sorry. So in case of the big rated ampere rating devices, switches, or ACB, MCCB, or big contactors, when they switch off or switch on, for sure there is a big surges is placed, as you can see. So this is also we classified as an indirect strike, but on the name of the switching surges. And this is the currently more and more we can realize from the analysis of the report, which make our loaded our devices will be damaged by the surges. So SPD is actually designed for exact this kind of transient over voltages, not like temporary over voltages. Transient means more than 12 times bigger and with very short durations, less than 1 millisecond. But those kind of the temporary over voltages we already know very well is not targeted by SPD. So you will see later what I'm talking about, but please remember SPD is only designed to protect the surges, but as a name of the transient voltages with a very high big energies, more than 12 times, and with 1 millisecond as a duration. Those kind of the over voltages we are easy to recognize. Do you know what products protected against this kind of the conventional over voltages? It's normally over voltage release as an accessory of the breakers. You may know that these are actually designed to protect those kind of general or nominal over voltages, but SPD is not protected by these general over voltages, but with very high energies and with a very fast the speed, I would like to say. So this is the purpose of the SPD, which is having a target to be protected. This slide is a bit more easier to understand. So A is a harmonic, and the C is a switching surges. When big contactor, big switches, big ACB, MCCB will make on, make off the contacts. and the indirect striker is a D, and the direct striker is E, with the biggest high energies, minimum high energies, and still very high energies, and A and B as a nominal over voltages with a high duration time is not designed for our SPD, but this EDC is the what our OBR QS SPD designed for the protection to our load. Hopefully so far it is clear. So now I will try to explain what type of the SPD in ABB or the other branded or in the market have. So to start to explain about type of the SPD, I have to coming back again about the type of the strike lightnings. So as I told, there is a direct strike from the sky to the lightning rod. This is the one of the type of the direct striker, and you will see this waveform 10-350 microsecond. You will see what is the meaning of this. So direct striker always have those kind of waveform. So now I would like to explain what is the meaning of the 10-350 waveform as a type 1. This is coming from the direct striker from the sky. So there is a peak ampere rating, like a peak surges on the name of the I imp. So when from the 0 to 90% of I imp, the time duration is a 10 microsecond, which means that within 10 microsecond, 90% of the I imp will be reached. This is the meaning of the 10 microsecond. And the next, the 350 microsecond is the time to be going down from the I imp as a peak level of the surge current to the half of the I imp. So it takes around 350 microsecond. So those 10/350 microwave form is the meaning of this graph, which is the having a direct strike from the sky, as always. And this is the picture for indirect strike. So not directly to the writing node on the houses, but to the other side, like a tree or a grounded or other electrical supply lines. When they hit in this area, of course, the waveform is the 10/350. However, when they going through to the other electrical lines, then this waveform will be transformed to the wave 8/20. Wave 8/20. So remember, wave 8/20 is the indirect striker waveform, which is the different of the direct striker waveform 10/20. 10/350. Sorry. So as a same logics, 8 means when 90% of I in this case is max, the peak ampere rating of the surges, it will take around 8 microsecond, and from the 100% I max to be reached half of the I max, it will take 20 microsecond. So this is the waveform as 8/20 from the indirect striker, including switching devices. You remember, indirect striker is including the switching devices from the big ACB, MCCB, or big contactors. So can you see the differences between the 10/350 microwave form from direct striker and the 8/20 waveform from the indirect striker here and here. Can you imagine what is the big differences between these two different waveforms? You may know these dimensions will be as energies. So direct striker having a much bigger energies rather than indirect striker, as you can see also waveforms, also meaning of the waveforms. How much differences is around here is the 10 times greater. So this, let's say, I max is like 10 kA, I imp is like 10 kA, but energies is 10 times bigger from this 10/350 microsecond rather than the total energy of the 8/20 microsecond. So having a characteristic for the energy point of view is a totally different level. That's the reason why we will try to classify the 10/350 as a direct striker waveform and the 8/20 microsecond as an indirect striker waveform. Why? Because this big energy, we need a different mechanism to discharging such a big different level of the energies. So Taiwan is one of the SPD product ranges designed to protect direct striker having a 10/350 micro waveform based on spark gap or gas tube. This is the symbol of this spark gap and the gas tube. Because this is the metal frame, so they are only one able to consume discharging the surge energies, peak surge energies to the ground. How it works? So this is the inside of the type of SPD in ABB. So when there is a surge going through as a 10/350 micro waveform, then in the beginning, these two spark gap is actually opened, but if there is a very big difference of the energy in between applied, usually arc is placed. So with this arc, this opened circuit will be closed. Then energies will be going through, and this will be closed, and the energies will be going through the phases and to the ground. This is the basic technology how spark gap gas tube will react against such kind of the big energy waveform from the direct striker. You will see now the movie clips how to operate the ABB new Type 1, Type 2 SPD based on the spark gap technologies. So always thin rail mounted. So this is the line cable, and this yellow and green is the terminal to the ground, as we know very well. So SPD always connected in between the phases and the ground, and this is the our aux contacts. When our inside of the spark gap have end of life, then this aux contacts will be reacted. So when a surge is going through to our Type 1 SPD, then you will see inside it. Normally it is open, but when there is a big different energy is applied, then there is the big arc is placed, and this arc will be connected from the phase to the grounded as bypassing such a big energy to the ground, not transfer to the load side. This is the how spark up is work to protect the direct strike as a 10/350 microsecond waveform. Hope it is helpful to understand. So in the past, ABB have over Taiwan ranges only, but now from this year we launched the Taiwan and Type 2 technologies, which is the more flexible and the more demanding from the customers, having a same the product performances against the surges, but having more various feature of the products. So you will see the raters. This is the one information just for your information. Okay, now we will see how to react indirect strike surge protection as a waveform 820 microsecond. As you can see, the differences comparing with the 10/350 microsecond waveform is a much more lower energy they have usually, 10 times less than Taiwan striker. In these cases, our ABB SPD installed MOB, methyl oxide birestor. This technologies-based the mechanism will be installed to discharging the peak energy from the indirect striker as a waveform 8/20 microsecond. So this is the MOB, so much cheaper than the spark up. So Taiwan Type 2, there is some price, different price positions because of the different technology inside it, because different waveform they protected. They have to be protected. Okay, so now we will see this QS, Quick Safe, one of our new technology already integrated in our OBI QS. Is this quick and safe. So this is the MOB as you saw in previous slide, and this MOB is normally connected by thermal connection technologies. But when this MOB inside of our OBR QS Type 2 is aging, having a lot of surgery cases they consumed, then this will be aging and getting the heat dissipation more and more. Then there is designed to be disconnected separately and with very safe technologies. This is the meaning of the QS, Quick Safe, for automatic thermal disconnection technology to make any risk of the fire, for instance, at the end of the life of the MOB technology in SPD Type 2. Now I will show you another movie clips how to operate.
Hello, AJ.
Hello.
Hi, we lost you for a few seconds there.
Yes, I try to play another movie clips, but it doesn't work.
Okay, so is it an animation or an actual video?
It's animation, actual video. Yeah, actual video. I don't know why.
Okay, maybe we can just share it at the end of the presentation.
Yes, I will keep going. Sorry for this.
No problem.
Yeah, sorry for my something is not well operated, but we will see later. So this is the actually what I try to show you how practically activated these quick safe technologies inside of our MOB when they reach the end of life. So when they reach the end of life, then this summer connection will be reacted automatically and to secure the safety for separated between live parted and the ground parted. So now we will see a bit more how we install the SPD. So like our computers and the final circuit, we will connect it from phase to neutral. And without SPD, before installing the load side like a computer, when the surge is going through from the indirect strike or direct strike or something like a switching surges, these big energies having a 6,000 K voltage level energies will be directly going through to the load, and this load like computer will be burned because of the surges. However, always SPD, if the SPD will install before the load side, then this load will be protected because SPD nominal status is the open, but when they reached UP, you will see later, protection level of the voltages, normally 1.5 kV. When they reach the 1.5 kV, then SPD will be reacted to make an open circuit to the closed circuit and bypassing the surge current to the ground. Then this load after SPD keep the protect as the same level of the UP 1.5 kV because SPD will react it and bypassing the more than 1.5 kV surges to the ground. So this is the target why we need the SPD is required to install before installing the load side. Again, so without SPD, our loader will be burned. But within SPD installation, in front of our loader, this will be cut if the surge is over the UP level, then the SPD will be closed and the lead energies be bypassed to the ground. This is the overall concept of the SPD operation against the surges. So one more slide just to better understanding how to work the SPD. So normal situation, the current is going through the first stream, second stream to the final stream at the end of our loaded with our cable. If our current is going through within the standard current ratio. However, when the surge is coming, then more than rated current will be going through the cable. Then these energies will make our load be broken or burned. Then SPD is installed. This SPD will let through the over energies, surge energies to the ground as a mainstream. So then every current is going through under the withstand voltages or withstand the level of the energies from the load. This is the how SPD designed it and reacted for protecting our loaded or even though our cable against our surge current from the direct or indirect strike. Now we will see what is the meaning of the IIMP, IIMAXs. So IIMP, IIMAXs, as we saw already in the previous slide, is actually saying peak surge current. However, according to the IC standard, there is the type 1 and type 2. So type 1 SPD for peak level of the surge current is called under IIMP. Type 2 for peak level of the surge current is called under IMAX. So meaning is the same, but according to the standard class category, only name is the different. But thanks to this, we automatically realize is that when they say IIMP, we have to look at the type 1 SPD or type 1 plus type 2 SPD. When we look at the IMAX, we automatically think we need a type 2 SPD when we try to select right product. Type 3, there is only IMAXs. And there is also UP, clamping voltages, and IN. We will see the data. So this is the quite interesting, how can I say, the table. You will see, we saw not only for IIMP, but also for IMAX, there is also IN as a nominal discharging current. Then how we understand these two different the value. So IN as a nominal discharging current is, you will see, is a total energy going through the SPD 20 kA, which means that 20 times of a nominal discharging current can be observed by our SPD, like a life cycle. Imax or IIMP, when IIMP is the 40 kA, only one time can be discharged to be protected. This is the how we understand that in between what is the differences between IN as a nominal discharging current and IMAX or IIMP as a maximum peak current. Every SPD have these two different value. You will see from our catalogs accordingly. Okay. So just one comment is that normally when we get the surges from our daily life is mostly less than 5 kA. So with the SPD, still we have enough life cycle if we living with this less than 50 kA. So 20 and 40 is really like extreme cases. Now we will see with the stand of the equipment as and the UP level. With the standard equipment according to this IEC 60364-4-54, there is the classified the withstand voltages for each equipment based on the rated voltages. So, for instance, South Korea 220. So when the equipment is classified as a category number 1, like TV, video, then this the load of the withstand voltages is 1.5 kV. For the others, 1.2. In case of the 22 to 2020, maybe could be case of the in Philippine market, the withstand voltages is classified accordingly. This is the very important the point when they choose the right SPD. We will see the later. So because as you can see, when SPD reached their own UP level, voltage protection level, then SPD will react and let the surge current be going through the grounded, bypassing the grounded, and protected the load after SPD installation. So always we have to remember the UP of the SPD as a voltage protection level have to be lower than with the standard voltages in person with the standard voltages of the load which will be protected by our SPD. So this is the another simulation tool. What is the meaning of the UP? So UP for this SPD is a 1.2 kV. So when the network will be reached until the 1.2 kV, then this load will be also applied at same level of the U network voltage level. But when they reach and over the UP of the SPD 1.2, you will see then this SPD will be reacted and the lead energy is going through the ground. Then the equipment will be kept as a same UP level. So this SPD based on this operation way to protect our equipment loaded against the surges. So UP and the withstand voltages, that's the reason why also very important factor to know. Now the final one is the backup protections. When we talking about SPD, we always able to hear the backup protection because in SPD, when they reach the end of life, there is a risk to be short circuit inside of this circuit, inside of the MOV side. That's the reason why we need a backup protection. So there is a 1, 2, 3, 4 different cases as you can see. So if there is the main breaker from the incoming side and the SPD will be installed by in parallel. When SPD short circuit level is bigger than rating current of this breaker, incoming main breaker, then this when they reach the end of life for this SPD and make a short circuit, then this incoming breaker can be disconnected. So there is no need to install additional breaker before installing the SPD side here. But there is one downside is that other network will be down together. So ABB usually promote to the customer, recommended to the customer to install another SPD from here. In case of the short circuit current, when they reach the end of life of the SPD here, is smaller than the rated current of the main breakers. For sure, in these cases, when this SPD will reach the end of life and make it a short circuit current is too small to break by this breaker. So we need another MCB or fuses dedicated to protect this SPD when they reach the end of life. This is as a backup solution. So this is the okay, but there is the downside to disconnect the other of the network. So normally ABB recommended to the customer to install another breaker and fuses to protect SPD when they reach the end of life. Every code of our SPD is presented what breaker, what fuses they recommended for the customers. And these two cases is actually not permitted by standard and also SPD. Also, this cannot be disconnected when the SPD will be end of life. So ABB, you know that we also have fuses with the fuse order and MCB. So we already tested from our laboratory together with our SPD, fully coordinated. This is the one benefit from our SPD. Only one provider for the SPD can offering together with the backup solution belong to the same company as ABB. So you will see and easy to choose what backup protection they need. Okay, time is very out of time, so I will try to speed up. Now we will see, so now we will see overall of the operation and the type of the SPD, type of the surges, just to better understanding of the SPD. Now we'll see another feature of ABB OVIQS. we have aux contacts here. So when they SPD will be reached the end of life, then this aux contacts will be reacted. So sending the signal to the users. Now we need to replace our cartridges. Another one is that we have an indicator to show the customer the end of life of the cartridges. But one is the without S is actually two steps only. Green in the nominal status, when they hit the end of life, is immediately turning to the completely red. But ABB have a benefit and the unique. We have another feature on the name of the safety reserve version small s. There is three steps, one steps more. So normally the green, when they reach the middle of the life, then half green, half red. And when they reach the end of life, is totally red. So there is one step in between green and red, and customers or users can see, time is coming to replace the cartridges before this cartridge life be hit end of life. So we give the chance to customer to avoid the downtimes. And another feature I would like to highlight, this aux contact, when they use type S, then will be reacted, switching the contacts when they reach the half green, half red. So with the S type as a safety reserve versions of our SPD is another benefit, and we are having a unique feature for the customer to avoid any downtime for their system. So like data centers or very high installation requirement reliability they need, our OBIQS with a small s version as a safety reserve versions is helpful for the customer demand. And cartridge basis. So when they reach the end of life, we also can see the cartridges in each product code of our SPD brochure and the catalogs. So you don't need to change the fully completed SPD. So you only able to change the cartridges only. So for the maintenance cost level will be also saved somehow. Another benefit we have is in the past we have a code for SPD according to IC, code for SPD according to the UL, but now one code having a both standard. So this is the another benefit. You just choose our one of the SPD without doesn't matter of the standard in between IC standard and the UL standard. So okay, now we have only 10 minutes. So how to choose SPD? So as of now, you may know almost of everything. When we need to choose the SPD, right SPD for your network. So first of all, we have to know this SPD will protect from strike, direct strike or indirect strike, or switching surges. So normally direct strike is a requirement from the first level as a main board, and the indirect strike or switching surges is like a sub distribution board or sub distribution board or final circuit board like a consumer unit. Then we know the UP level, voltage protection level, which our SPD will be reacted and the LED energy going through to the ground. Also, we have to know the withstand voltages from the load for sure. So you remember UP should be lower than withstand voltage from the load or equipment. Also, we have to choose IIMP or IN. Actually, we already know when we realized this SPD will be protected against the direct or indirect. So direct is 10/350 microsecond as the name of the IIMP, and the indirect is 8/20 microsecond as the name of the IMAX. And the level of the voltage we have to check, and other functionality we have to check. Cartridges or safety reserve, as you remember, three different steps for indicating end of life, and or remote signal like aux contacts you need or not. So those kind of information, if we can verify that, then we can choose the right code of the SPD for your protection of the circuit. Okay, so now I will very briefly show our product ranges. Here, as I told you before, now we launched the new Taiwan Type 2 SPD, as you can see. So in the past, we have a Taiwan only, but now we invited Taiwan Type 2 technology altogether inside of this new ranges, having all functionalities from the Taiwan SPD in the past. So don't worry about the performance side. As you can see, IIMP under the Taiwan Type 2 is still 25 Ka, as the same as the OBR Taiwan we have. This is also another video. I'm not sure it works, but because of the time running, I will skip it. And the Type 2 ranges you will see here from the 1 pole, 2 pole, 3 pole, 4 pole, and 1 plus neutral, 3 phases, 1 neutral, and 3 phases, and 4 pages, depending on the network which our SPD will be installed. We will have a different number of the ports. Okay, maximum 80 Ka as 8/20 microsecond on the name of the IMAXs Type 2 or our SPD, up to the 690, up to the 760 voltages AC. With the and the only Type 2 is having this safety reserve system, 3 steps. Type 1 and 2, we don't have a reserve system, just for your information. We have also SPD integrated with our MCB as a backup. So this we call OBI Plus, which is the more benefit for customer, not only for the dimension side, but also for no need to install one by one, all aspected. This is the also quite convenient for the customer. And also we have OBR T2, T3, like a SL for street light, because recently, I believe in Manila, Philippines as well, the street light is changed as a LED basis. And this LED basis having a PCB board circuit as a driver, as a name of the drivers to operate the LED. And this driver, unfortunately, very weak against the surges. So when driver is burned by surges from direct striker or indirect striker, then we need a lot of the money to pay the cost for the maintenances. That's the reason why ABB have developed this straight light SPD for specific LED street light. This is the pictures of the reference from South Korea in the park. So here we can install the SPD for the street light for better maintenance point of view. Another SPD we have for photovoltaic for DC level up to the 1500. And this is the picture for our ABB combiner. You will see the SPD in here up to the 1500. And the one benefit, very unique, the feature of our OBR PV photovoltaic application is no need to backup up to the 10 Ka as a short circuit expectation value when SPD will be reached the end of life. So like a PV installation, there is no stored energies. So even there is the short circuit, there it is very difficult to over the 10 kA. So normally this means that ABB over PV no need the backup in PV installation, in solar installation, in photovoltaic installation, not the battery installation. So this is another feature. So we can also deliver some benefit from for the customers because they don't need to anymore to install the backup for protected this type 2 surges in DC application. Another products we have, you may see this kind of a box type SPD on the name of the TVSS. So when we need those kind of the box type of the SPD, for sure ABB have. So please do not forget. It is always happy to know, to get your inquiry, all kinds of the SPD from your customers or from your demand. Last, we have a lot of the Markham tool, leaflet or videos, what you saw it. Unfortunately, 2 video was not working well. And newsletters, product pages, images, technical presentations, everything we are available. So please let me know any kind of the information assistance you need. Please feel free to contact my teams in ABB Philippines, Carla, and other our colleagues. I should stop, sir, because now 2 minutes only left. Sorry, Vanity. I use a lot of time, sir. So if there is still time to answer your question, let's start. Thank you once again for your time.
Thanks so much, Gigi. Don't worry, we have time because we have a lot of questions. So we'll just let you catch your breath, and then what I'm going to do is I'm going to share some videos which you were supposed to share early on during your presentation. So right now I'll be playing this video, the one that you've mentioned, which has no audio, so that you could do your voiceover. So I'm playing it right now.
Thank you very much. Thank you very much. Yeah, so this is the quick save, the demonstration, the movie clips. Now we can see. So in the normal status, when the surge is going through, still the indication is green. And you will see this thermal disconnection technologies is safer in the normal situation. But when they aging, then this part will be having the heat. Then these technologies, as under the quick safer, will be designed to automatically disconnect it. Then you will see the red colors on the right side from the front of the indications. This is and we need to replace only cartridges. And you will see the aux contact reaction is changed again. So hopefully you will have to understand how react each kind of the part inside of our type 2 quick safe ranges among the aux contact part and the indication window from the products and inside of the thermal disconnection part. Thank you.
Okay, at this point, I'll be sharing the other video, JJ, that did not play. So let me just put it out for you and the rest of our audience.
The last one is just to show the product overview. So if it doesn't work, maybe we can skip it. Okay, now you will see. This one I shown to the participant already. So somehow to show how our spark gap technologies will react against the direct strike surges. So when the surges is going through, like the black one, to the OBR type 2, then inside, based on the metal frame on the name of the spark gap, is normally open, but when the energy is going through and make the big gaps in between, then the arc is happen. This arc will be connected in between phase to the ground. Then energies will be going through to the ground. So this is the basic concept of arc spark gap operation against the protection against protecting the surges against the direct striker having a 10/350 microsecond waveform.
Okay, so were we able to play the video, or did we miss another one?
Mm-hmm.
JJ?
Yes.
Yeah.
Hello.
You want me to flash the product range?
It depends. So we already out of time. So this is just for product range show.
Okay,
So may
sure.
not
So
very
what I'll do
important.
is,
Yeah.
yeah, what I'll do is some of them are already asking if we could share the today's presentation with them as well as the video clips that you have shown.
Yeah. We of course can share everything. I already send it to our local product marketing manager, Carla. So Carla can support you to get this presentation file after finishing this training.
Okay, perfect. So now we can go to the questions that we have.
Yeah.
So, okay, let me just read out some of the questions that we have lined up for you. And while I'm scrolling down, you have to know that we have a very, very good audience this afternoon. I'm not sure if you were able to read out hear the earlier greetings, but we have the Metro
Yeah.
South chapter of IIEE in attendance.
Yeah.
So
Thank you so
we
much.
also
Yes.
have people from IIEE Oman and IIEE Singapore. We have attendees from Cebu, Parañaque. We have people from Iligan. So we have a very good attendance this afternoon. Okay. So let me just read out the questions. Okay. The first question is, how is arc flash related to type 3 surge of switching?
How? Sorry, I couldn't follow your questions. Sorry.
How is arc flash related to type 3 surge of switching?
Type 3 is actually same the demonstration of the operation as like a type 2 based on the MOB, which we saw like a QS quick save the movie clips before starting this Q&A session. How we classify the in between type 2 type 3 is only level of the surge current, but based on the same technologies. Of course, the level of the surge is lower than type 2. So sometimes there is the SPD on the name of the type 3 based on the diode only, not the metal oxide biresistor. But the operation way is actually same. Type 2 can serve it. This type 3 level of the surges as well. And there is another SPD as a name of the type 3 based on the diode mechanism inside of the SPD, just for the price positionings, which is still have to be lower than type 2 ranges. So I would like to say it's the same as the type 2, what we saw in the movie clips before starting to Q&A session. Hope this is the answer for his question.
Okay. The second question is there a design calculation or formula on how to compute what type of SPD to be used, just like a circuit breaker KIC rating in relation to short circuit analysis and protection coordination?
This I have to check, but we have to remember this when we say discharging current as a KA, 1000 ampere rating. I understand that it looks like a similar breaking capacity what you told about the short circuit KIC rating. However, the meaning of the discharging and the short circuit rating, the breaking capacity ratings from the circuit breaker is a totally different concept. So I doubt that there is some formula which is linked in between this discharging current from SPD world and the breaking capacity in the breaker world. But I will try to check it and come back to you. Sorry not to directly deliver the right answers.
Barbs, Miss Barbs, hello.
Yes.
Hello.
Go ahead. You're receiving.
Yes, hi. This is Job. Yeah, if I may add an answer to the question, basically there's what you call the IEC 62305, which is a standard for risk assessment. So this is a good reference in selecting the type of SPDs to be used. On the other hand, JJ is correct earlier. We should treat in IEC world, we usually treat the SPD and the circuit breaker as two different protective functions. So basically, circuit breakers function only for overcurrent protection, while SPDs function for overvoltage protection. So just to keep it simple. Thank you.
You're right.
Sorry. Thank you, Job. Thank you for that. The next question is, are modern appliances equipped with surge protection? Some power strips are equipped with surge protection. What is the main difference between these types of surge protection and the ABB SPDs besides being installed across the line? Hello?
Oh, hello. Sorry, I also missed again your question. Maybe better to see. Can you repeat one more time? Sorry.
No problem. So are modern appliances equipped with surge protection? So that's the initial question. Then he mentioned some power strips are equipped with surge protection. What is the main difference between these types of surge protection and the ABB SPDs besides being installed across the line?
If I may understand correctly for his question, appliance, general appliance, like our relay, for instance, like timer relays and any kind of relays or protection devices protection relays, is input. There is always installed capacitor and resistance. So capacitors is designed to protect surges, and the resistors designed to protect over current. So the question from him is that what is the differences between these capacitors inside of the equipment and the ABB separated SPD? If this question is right, my understanding is correct, is the differences. The main differences is the discharging the surges. The level of the surges is totally different. I mean, in this kind of the capacitor, which is the integrated input circuit of the equipment, is a very less level of the surge current can be observed, can be discharging. However, like a 20 kA or 40 kA microsecond, as I imp cannot be discharged with this integrated capacitors in the equipment. So I have to say it depends on the level of the surge current, thanks to the indirect strike, direct strike. The capacitors inside of the equipment, the level of the protection for surge is relatively very low compared with the ABB or other SPD unit.
Okay. Next question, JJ. You mentioned the local government units are required to submit a short circuit analysis before you can be issued an electrical permit. So he's asking, do you think it is high time that we should also include voltage surge study? If you agree, how can ABB help on this? Thank you.
Jobs, you have any comment for this?
Hello. Yes. Sorry, Miss Barbs. I can't find the question. Can you repeat it again? Sorry.
No problem. I'll just repeat it for you. The local government unit is required. The local government unit are required to submit a short circuit analysis before you can be issued an electrical permit. Do you think it is high time that we should also include voltage surge study? If you agree, how can ABB help on this?
Well, actually, well, based on the Philippine Electrical Code, it doesn't stipulate any requirement for voltage surge study yet. But once we adapt the IEC 60364 standard, which requires installation of surge protection devices on critical equipment, maybe that is the right time to implement the probably what you call the risk assessment for the implementation of installation of short of surge protection devices. But at the moment, what we can do probably from ABB is basically to help out the consultants and the contractors, the developers, the end users on how to size up properly which SPD to select depending on the application, because you have to consider a lot of things when doing designs of surge protection devices. You need to consider the location, the type of equipment that we need to protect, the distance from surge protection 1 to surge protection 2. So there are a lot of things to consider. And there's IEC 62305 to guide us in risk assessment, and at the same time the ABB technical team is here to support on any requirements needed for your projects.
Good. So I think we can help JJ also in the next question, because this concerns some local flavor. So the question is, in your presentation, according to a Viva study in France, damage to equipment, voltage surge is more frequent at 61% than short circuit at 6%. Here in the Philippines, the engineering department of the Office of the Building Official of all, the question got cut. So we can go back to that. I'll just proceed to the next question. Then this is the question: is the size and length of the ground wire affects the function of the SPD?
Yes. This is the definitely yes, because of the size and the length of the wire to be connected to the grounded is also somehow to influence of the internal impedance of the wires, which is the impact for SPD performances. So there is a rule actually I didn't show you about the name 50 centimeters rule. So this means that the length of the SPD from the ground terminal to the rear ground have to be within 50 centimeters rule with some specific cable. I will also send it back to you after I check some detail.
Sure. That
Yeah,
would be
but
great.
there is a clear rule as a name of the 50 centimeters rule. In between the length from the terminal of the ground to the rear ground, like a PE side. Yeah.
Okay, let's go to the next question. So next question is, okay, what is the minimum value of the earth resistance for an SPD to be effective?
Yeah, this should be also linked to this 50 centimeters rule, if I'm not wrong. So, as I told you, there is a rule on the name of the 50 centimeters, the length in between the terminal of the grounded of the SPD and to the rear grounded terminal. So hopefully this will be something helpful for your question. Otherwise, let us know later. We will verify your question separately. Sorry for most of the question. I actually worry about there should be a lot of the question very high tech and the complex questions because you presented some of the customers from the Metro Manila, IEEE. So I was happy, but automatically coming very concerning about question. Do I really have to do it immediately or not? But sorry, as you can see, mostly I cannot reply, but we will see one by one.
Yeah. Okay. Let's have this another question. Is the ground connection of the SPD to be connected and bonded to the system grounding, or should the SPD be connected to its own separate ground rod?
Oh, it's okay to connect it to the grounded, like we here in South Korea say, like a enclosure grounded. So should be okay to share the grounded. It, maybe no need a separate grounded.
Okay. Do you also have medium voltage surge protection solutions?
Yes, we have on the name of surge arrestor. You may remember from my beginning of the slide. SPD in medium voltages, they usually say surge arrestor. So we ABB have a surge arrestor for the medium voltage network on the name of the surge arrestor. So please also contact us if you have any demand.
Okay. Do you have, I'm not sure if I've asked this already, do you have a selection guide for choosing the correct SPD specs?
We show briefly my slide, so you will see when you receive my presentation from our colleagues in ABB Philippines for sure.
Okay. Let's see. I'm just going through the Q&A box. So, okay, how do you determine the correct KA rating of the SPD? How do you calculate this surge current?
This is the quite difficult question, to be honest, with you, because the SPD, the discharging current, I maxes, unfortunately, defined it from the customer side. Since we, as ABB manufacturers, produce the ABB, the level of the discharging current according to the standard. So This actually we have to get your support.
Okay. We have one question that we are not able to address because it's kind of incomplete. So this is about the question with Aviva rating. So if you could just send in back that question and complete it, we would be most happy to have it answered for you. And okay, I have a message here. They're asking about for IIEE South um, engineer job. Mayo has posted the link at the chat group, so you could click that link. I think it has something. It's for your attendance or registration. So Engineer Mayo has posted it here, and you can just click it so that you could access and input your name there. Okay, let me just run back again to our Q&A, JJ. We have very good feedback here, and a lot of you, for those who were not able to hear it, yes, we will be sending today's presentation. JJ will be sharing it with us, and then together with the video links that he also showed to us, we will be sharing it with you. Just please answer the feedback survey. The link is posted at the group chat so that we could officially secure your email addresses and send back the materials to you. Okay?
Okay.
Okay. Again, we'd like to thank our members of IIEE Metro West. Maraming salamat po for encouraging your members to join us and for being, some of you are regular names, so I know you are a regular of our webinar sessions. IIEE Metro West, IIEE Metro South. We have IIEE from Singapore and Oman, and all of the regular attendees of ABB Philippines Webinar Series. So those of you are asking for our updated lineup of webinars, we will be posting it in our website, but we have already calendared sessions until December 2020. So what we'll also do, we have taken note all of your questions, and we'll ask our group of experts together with JJ to answer it for you, and we will be sending it out together with today's presentation and your certificate of attendance. Okay? So with that, maraming salamat po in behalf of ABB Philippines webinar team. Thank you so much, JJ, for doing this session with us, and we look forward to doing more sessions with you and with our colleagues from the ABB community. So maraming salamat po, and see you in our next session. Keep safe po, everyone. Salamat.
Thank you. Thank you for everybody one more time, sir. Keep safe yourself against COVID-19. Thank you.
Thank you, JJ. Thank you, team. Maraming salamat po. Have a good day.